Hello friends, I have already discussed what is the embedded system and what are the real life example of the embedded system. Now by giving the example of the embedded system, I will discuss about the how many types of the embedded systems are available in our daily life. So first I want to discuss about the network based embedded system. Okay, in case of the network based embedded system, normally the circuit, the system that is totally depending on the network. Okay, so if we have the multiple embedded system, each and every embedded systems are connected with the network. So there will be in this embedded system, network to network connection is there. Okay, so network may be the LAN, that is local area network, or it may be wide area network. First, each and every components of the particular embedded system that is connected to the local area network, and after that, network is transferred to the wide area network. Okay, so the connection takes place between the network, one network to another network, one network hub to another network through the different routers. Okay, so normally it is also called as a distributed network system. Okay, so it is not it's too much complex circuit or not a too much small circuit. So in case of the network based embedded system, if I think so, smart security system or office security example, office security system. In case of the office security system, this provides the security of the office. Okay, so here different kind of the sensors are connected. That is smoke sensor, smoke detector, motion detector, and light sensor. Okay, these are each and various kinds of the sensors are connected inside the embedded system, and so if you want to check the whether the someone is there or not in office, and if you want to check there's some motion, so in any kind of the vibration, anything is there, that thing can be detected, and if anywhere any location of the office is light is already turned on, we can turn off the particular light. Okay, so but for that we need a network system. This system is also called as a security, the office security system. This is one of the example of the IoT. So I have already started the IoT lecture. You can also see my IoT lectures. Okay, so the office security system, this is a example of the IoT also, and this is also one kind of the network based embedded system. Okay, so here, so to observe this thing, to observe the sensor output. Okay, we need to collect the sensor output, and that will be transferred into the cloud. That is only related to only network system. Okay, without network we cannot analyze those sensor data, right? So that's, so it is the network based and another embedded system. And any kind of the IoT, okay, any kind of the IoT device that is also related to IoT devices. These are also related to network-based embedded system. Okay. Next, come to the second point. Real-time embedded system. Okay. Real-time embedded system. In case of the real-time embedded system, normally it needs the quick response. Okay, it needs quick response. Okay, and quick action need to take. Mm. Okay, so immediate action need to take place for case of the real-time embedded system. For case of the real-time embedded system, we need to take the immediate action. Okay, so what are the examples of the real-time embedded system? Normally need a quick response. We need to design a such kind of the embedded system which builds the quick response. Okay, which builds quick response, and immediately they can give action. Okay, so immediately they can take action. They will get the sensor output, and that accordingly they will give the action. Okay, so Normally, what kind of the example you can give? Normally, this kind of the real-time memorization, this is normally used in the medical applications as well as the military application. Okay, medical application normally used in the medical and military application. Okay, so guys, so as the quick response is required, so normally we need to design a hardware, okay, in a proper way. Sophisticated hardware is also required, so to avoid the failure. Okay, if there any failure is there in that system, it will not give the quick response. Okay, so normally in building, okay, in the elevator, in the for light and for door in the smart building, we need the real-time embedded system. Okay, and apart from that, in medical, in military application, if you want to track any kind of the weapons, okay, so for that also real-time embedded systems are required. Okay, I'm writing here what are the types. That means here mainly features is that mainly proper hardware is required. Okay, proper hardware is required. Okay, and to avoid the failure anyhow. Okay, anyhow you have to avoid failure. Okay, so what are the mainly I told the military and medical application you can use this, so and the real time embedded system. Okay, so in military, track any weapons. Okay, and in case of the medical application, you can do the surgery, radiotherapy. Surgery and radiotherapy, this kind of application you need to use the real-time embedded system. Apart from the robot, for robot also you need to apply the real-time. Robot can act immediately. Okay, so for robot also need to, robot is also under the real-time embedded system. Okay, robot. Okay, these are the real-time embedded system. So mainly you need a hardware, okay, which can give the immediate action. Okay, you need to, and timing analysis. Okay, you need a timing analysis for that also. Timing analysis is also required, as the name is the real-time embedded system. That means the timing analysis is also required. Okay, so hardware, software are also required for doing the timing analysis, and the proper hardware is needed. Right. Next is the. Next is the third point is standalone embedded system. Okay, standalone embedded system you can write also as a ES. Okay, so standalone embedded system, in this case you don't need any computer. Okay, don't need any kind of the computer in case of the standalone embedded system. Okay, so what are the examples if you think in the for standalone embedded system? Main examples are the, so if you think, I already told the washing machine, microwave, and these are the under embedded system. Okay, so even don't need any kind of the computer. Okay, for implementing such kind of the standalone embedded system. So microwave oven, digital watch, and one thing I told, washing machine. So how this system will work? Normally, so for each and every component some sensor will connected. The sensor, so we are providing some input from our side, so that will be transferred into the electrical signal, okay, by using the sensor, and the processor will process the output, okay, modify the output based on their application. What is the function of a microwave oven, and what is the function of digital watch, and what is the function of washing machine? Based on their application, processor will give the output. This for observing those output, you don't need any kind of the computer. There will will be the one display system. So this system is connected to each and every component. So we can see that modify output or process output in the display system. Okay, you can see how modify output of the process output in the display system. Okay, so sensor input, that is connecting to sensor, then processor, then actuator, which providing the output. Okay, output, then display. Okay, input, sensor, processor, actuator that provides the output, and the output you can see in the form of the display system. Okay, in the form of the display system. So these are the example of standalone embedded system. Last but not the least, so last example is the mobile embedded system. Okay, mobile embedded system. So normally the embedded system which relates to mobile, inside the mobile we can build the such kind of the embedded system circuit. Okay, so first is the cellular phone, digital camera, MP3 player to listen the music, to capture the video or photo, and cellular phone. Okay, so these are the under mobile system. So inside the mobile such kind of the apps are there. For this building those kind of the apps we need the embedded system. Okay, which are doing this, each and everything are doing each individual work. Okay, specific work they are doing. Okay, so these are the under the mobile embedded system. And MP3 player, this is also one of the example of the standalone embedded system. Okay, so there are the two kinds of the MP3 player. One is the music system you are installing on your phone. Okay, that is the mobile embedded system, and you can you have the different kind of the MP3 player. Okay, the hardware. Okay, so the analog system hardware. So analog MP3 player, the speaker box is also there. You can listen. You can put a CD and you can listen the music. Okay, so and something you can that will be the name of the music. This will be display on the MP3 players, display of the MP3 player. Okay, so so MP3 player is example. Digital MP3 player is an example of mobile embedded system. Analog MP3 player is an example of the standalone embedded system. We need a mobile. Inside the mobile, we can create a small embedded system chip which is providing such kind of the application: cellular phone, MP3 player, and digital camera. Okay. Next, so these are the apart from these four types, you can divide the embedded system in three different ways. Okay, small scale. Okay, medium scale, large scale. So in this case, that means small level of embedded system is there. Okay, a small level of embedded system, right? Medium level of embedded system and the large scale of embedded system. Okay, in case of the small level embedded system, normally in on chip ROM is there. On chip, in case of the embedded system, on chip ROM, RAM, and for this case external. From here also external. Okay, so this is about the ROM RAM. Now come to the hardware and software. Okay, for case of the small scale, okay, so it is doing normally the specific task and small, it will be very small. Okay, the medium to complex task. Okay, here only the complex task can be done by the large scale embedded system. Okay, now so you can only do this on specific tasks and which is very small, and medium to complex task can be done by the medium scale embedded system, and it can be complex task can be done possible by only the large scale system. Okay, now for this case only the hardware knowledge is required mainly. Okay, hardware like data communication, digital and analog electronics, then control system. The people those have such kind of the knowledge, they can build a small scale embedded system. But for medium scale embedded system, you normally need the hardware knowledge as well as from the software. Okay, what are the knowledge? C, C++, Visual, C++, Java. These knowledge are mainly required. Okay, from the software, the small, simple language you need. Okay, but for case of the large scale, you need the complete hardware. The various kind of the hardware knowledge you need, as well as you need the software knowledge. You are assembling all the hardware and software like so higher level of software. Okay, higher level, mainly Python, Java, and different IDE. Okay, different kinds of the IDE is also required. Okay, for case of the large scale system. Okay, now come to the what are the examples of these three systems. Okay, I have already told what are the main features of these three systems. Okay, so main examples of these systems are, okay, here I told that specific task. Okay, for small scale. So automatic door lock. Okay, washing machine. Okay, so for that, no hardware, no software is required. Okay, you can easily build automatic door lock by using the hardware component. For washing machine also, by using the hardware component, you can build the small scale. You need the PLC control system knowledge is required. Okay, for that small scale or for building the washing machine. Now next is the medium scale. For medium scale, you normally ATM. Okay, and other thing is the traffic control. Okay, radar. Okay, different kinds of speech processing, you can use the medium scale embedded system. In communication, different communication, you can use the embedded system. Apart from the traffic control, radar, ATM, you can use the medium scale embedded system and different communication system. Where you need some coding knowledge, C++, this knowledge is required. Okay, for case of the large, mainly the each and every components are very much complex. For this is the complex embedded system. Okay, so where in MRI machine, it can perform the distributed work. Okay, and in MRI machine you can use the large scale embedded system. Okay, in MRI machine, CT scan machine, different medical application or different military application also you can use the large scale embedded system. So this is too much complex. Okay, you need the various kind of the hardware and the software knowledge for building the and different biomedical knowledge is also required for building this thing, MRI machine, right? So these are all about the different types of the embedded system. So in the next lecture, I'll start with the how the embedded system will work and what are the and regarding the different structure of the microcontroller. This I will discuss in the coming microcontroller embedded system class. Thank you.